In the previous video we have seen Tower of Hanoi problem. In this video we will see n queens problem. So what is n queens problem? N queen problem is to place n queens in a n by n chessboard so that the queens don't threaten each other. So if you're not aware how chess game works, I'll show you an example. So this is a 4 by 4 chessboard. Usually the chessboard will be 8 by 8. I have taken an example of 4 by 4 board for simplicity. A queen can threaten other pieces in the same row or column or in the diagonals. Since it can move horizontally, vertically or diagonally, any pieces which is placed in its horizontal, vertical or diagonal is said to be threatened by it. So as you can see, these two queens are threatening each other. Same in the case of these two queens. Even though the color of the queen is same, we'll not be considering the color in this problem. And in the second chessboard, you can see these two queens are not threatening. For the first white queen, it can move vertically like this, horizontally like this, and diagonally like this, but it doesn't threaten each other. If this queen is not threatening this queen, that means the other way is also true. But in this board, we have only two queens. Our problem is to place n queens, that is four queens in this case. So here is a way how we can place four queens in a 4 by 4 chessboard so that they don't threaten each other. So how do we arrive at this solution? That we will see next. So we solve this solution by placing one queen at a time. So first let us place the queen at the first row, first column. Then I cannot place the queen below it. So I should consider placing it in the next column. There are four rows in the next column. So the first one I cannot place because this will threaten horizontally. I cannot place it here. It is diagonally threatening. Yes, I can place it here. These two queens are not threatening. So in this setup, I try to place the next queen. I try here, but this is threatening. I place it here, but this is threatening diagonally, and I place it here, and the fourth option I place it here, still it is threatening. So if we go this way, there is no way we can place four queens so that they are not threatening each other. So we go back a step. We have already explored three options here. We will explore the fourth option. So let us place the queen in the last row here, and the third queen I place it in the first row, but this is threatening, and I'll place in the second one. These three queens are not threatening, so I'll try to place the fourth queen. First row it is not possible, second row is not possible, third row it is diagonally threatening, fourth row also we cannot place, so this path is also not feasible. So we go back, we explore the third option here. We place the queen in the third row, but this is threatening. We try to place it in the fourth row. Here also it is threatening, so we go back. All the four options are done here. Again all the four options are done here, so we again go back one more step and we explore by placing the queen in the second row. So we try placing it in the first row. It is not possible. Second row is also threatening. Again third is threatening. Fourth we can place. So we will place the third queen now. We'll place the third queen in the first row. Now these three are not threatening each other, and try to place the fourth queen here. This is threatening, and here again if we place it in the second row, this is threatening, and we finally place it here in the third row, and we can check none of the queens are threatening each other. So we have arrived at this solution. As you may have observed, as soon as we reach the dead end, what we do is we go back and try the alternative path. This type of solving the problem is called backtracking. So in the next video we will see how to implement n-queens problem using JavaScript.